All right, y'all, we're looking at the very beginning of our topic 14 notes. Front page has this on it, identifying prisms and pyramids. Okay, that's the first step of what we're looking at today. We're talking at the very beginning here about prisms. Okay, that's the first thing to fill in that blank right there. A prism is a solid with two parallel congruent bases joined by faces that are parallelograms. Okay, so I don't think anything that's in this section of notes is going to be groundbreaking, earth-shattering news. This is pretty standard stuff. This should all be stuff that you've heard of before. Okay, prism is a solid. It's a three-dimensional solid shape. It's got two parallel congruent shapes on each end of it. Okay, it could be on each end or on the top and bottom, just depending on how you want to look at it. A prism is named by the shape of the base. Okay, so that shape, whatever that shape is, when there's two of them on either end of the prism, or the top and bottom, depending on how you're looking at it, that is called the base. It is joined together. The sides of the two bases are joined together by the faces. Okay, most of the time the faces are rectangles, though officially that's not necessarily the case. They can be just regular parallelograms, as we see right there. But generally, you've got two triangles or two squares or two uh, pentagons. It could be anything, and they're joined together by a bunch of rectangles. They connect side to side of those shapes, connected by rectangles. So there's a couple of things that are identified in these diagrams right here. The bases and faces are both very clearly pointed at, but it also points at an edge. Okay, I'm going to go ahead and outline a couple of them that's pointing at here. This right here would be an edge. This could be an edge of a prism. This right here could be an edge. Okay, any place that connects the corners of any of these sides of the prism would be considered an edge. It's one of the most self-explanatory definitions we've had all year long. And a vertex would just be a corner. I'm putting in green what a couple of examples of what a vertex could be on a 3D shape. So, as we look at the bottom of the page, it's asking you to name each prism, and within each one of them, identify a base, identify a face, an edge, and a vertex. Okay, so those right there are the names of these three things. The first one is a rectangular prism, second one's a triangular prism, and the third one is a cube. So a cube is just the shorthand for a square prism. Okay, it's where all of those the bases and the faces are all the same size of square. A rectangular prism, you don't necessarily have to write down all of the things that are behind this panel, but I do want you to write down at least one or two of them because in a multiple choice format, any of the following things would be good answers. Okay, so it asks you to identify a base. I'm looking at the rectangle on top, A, B, C, D, and the rectangle on bottom, E, F, G, H. Those would be bases. Okay, the faces would be the front and back, the left and right side of that rectangular prism. Okay, any of those right there would be a good choice for what a face would be on that prism. When you talk about an edge, that is the direct connection, the direct line segment in between two of the points. So I'm looking at line segment AB, line segment BC, line segment CD. Any of these right here, any of that whole entire list right there would be a good choice for what an edge would be if it asks you to identify an edge on that prism. And the last thing is identify a vertex. Any of those points, A through H, all of them are located at corners where multiple edges all come together at one single point. So all of those points would be a good answer for identifying a vertex. Okay, up next we've got a triangular prism. So the two triangles, MNO and JKL, those are your bases. The faces are the rectangles in between them. I'm looking at JMOL, JMNK, and KNOL. Any of those right there that are listed, any of those could be considered edges. And just like before, any of the points listed right there could be considered a vertex. Okay, any of those points where you've got multiple edges that all come together at one spot. On a cube is kind of funny because it's a little bit different because the faces and the bases are all the same exact thing, the same exact shape at least. The faces and the bases are all congruent to each other on a cube. So generally, it's going to go by the notation where the base is the bottom, the base is the bottom and the top, and the faces are the squares on the sides. Okay, that's how we came to this conclusion right here. The edges would be any of those. Any of those right there would be considered edges. Just the direct line segments in between going along the edge of the shape. It's very self-explanatory, and just like before, a vertex could be, you could call any point on that whole entire cube a vertex as long as it's at a corner. Any of those listed points could all be a vertex. Moving on now to the next page, we're looking at the first blank. It says it is a pyramid. A pyramid is a solid with a base that is a polygon and sides that are triangular and meet up at the top. Okay, so just like a prism, a pyramid is named by the shape of its base. So you could have a triangular pyramid where you've got a triangular base. You could have a rectangular pyramid where the bottom of your pyramid is a rectangle and you've got triangles attached to the sides of the rectangle that all meet up at the top. And a hexagonal pyramid is just another example. Okay, it's got a hexagon. It's got 6 sides around the base of that pyramid, so that'd be a hexagonal pyramid. The next exercise right here is just asking you to name any of these. Okay, you've got a 4-sided shape across the bottom. That's a rectangle. Okay, so it's a rectangular pyramid. You've got 6 sides on this one, so it's a hexagonal pyramid. You've got a triangle base on this one, so it's a triangular pyramid. Okay, don't overthink this. If we had 5 sides around the bottom, if we had a 5-sided polygon on the bottom, 5 triangles that all met up above it, it'd be a pentagonal pyramid. If we had 8 sides and 8 triangles that met up above it, it'd be an octagonal pyramid. Okay, don't overthink this stuff. Just look at it what it is. All we're doing is identifying that figure. That's all we're doing here. Okay, up next, we're going to do a quick little bit of review about areas. And we're going to do this review about areas, and you're going to see why here in a second, okay? All of these formulas we have already looked at. Rectangles you've seen basically since 4th grade, length times width. Triangles you've seen since middle school, 1/2 times base times height, or BH over 2 is the way we usually put it. Trapezoids you have seen before. That's what we dealt with, particularly in topic 13. You've got to have 3 things. You plug in both of the bases, you add them together, and you multiply that times the height times 1/2. I guess I went through that backwards, but that's what it is. Okay, so on these 4 example problems, again, don't overthink this. Problem number 1 is just a plain old rectangle. Length times width is 9 times 4, so we get an area of 36 square centimeters. Problem number 2, our base down at the bottom is 12. Our height, when you drop straight down from the highest point to the lowest point, is 10. So that means we're going to multiply 1/2 of base times height. Well, that's 1/2 of 120. So our area is 60 square meters. Problem number 3 is a trapezoid. And on a trapezoid, you have to remember that the bases, those 2 things that you add together in the formula, are the sides that are parallel to each other. So I'm looking at 10 and 7 as our 2 bases here. So that's what you're going to add inside of the parentheses. The height is the distance in between those bases. So just because this trapezoid is turned up on its side, that doesn't mean 5 is a base. 5 is still considered the height on this trapezoid. So it's 1/2 times 5 times 17. You simplify that all the way down and get 42.5 square feet. Okay, our last one, problem number 4, is a weird looking little shape, but you need to think about what is the definition of a trapezoid. Okay, on a trapezoid, you have to have 4 sides, and 2 of the sides are parallel to each other. So when I look at this shape right here, I'm looking at this side. Let me use a different color. I'm looking at this side right here and this side right here are parallel to each other, and those other two sides, they're not congruent, they're not parallel, they're not actually related in any particular way other than they're just right there. Okay? This funky looking little shape right here, by definition, is a trapezoid. So that means we're going to treat it just like we did number 3. We're going to go 1/2 times the height times the bases added together. So that's going to be 1/2 times 6.5 times 16. And we just simplify all that down. Half of 104 gives us an area of 52 square inches. Okay, so the reason that we're going back over these areas is so that when you look at a prism, you can figure out what's supposed to go on when you find the volume. Okay, ultimately, that's one of the goals that we're looking for today, is to find the volume of a prism. Okay, on this next page, you've got a couple of examples of a cube and a rectangular prism. And this is something that you've known how to do probably since 6th or 7th grade. Okay, when you're finding the volume of a rectangular prism, you multiply length times width times height. That is a formula you're already familiar with. I know you are. Okay, but I want to draw your attention to something right here. When you're looking at that formula, length times width times height, look at just this front little part of it right here. What I just outlined, what I just put inside of parentheses, the length times width, that right there is the area of just a plain old rectangle. Okay, if we're looking at this prism, we can find the area of this rectangle that I just outlined by doing length times width. Okay, that would give us the area of just that. Okay, when we multiply that area of the rectangle times the third dimension of height, that is what gives us the whole entire volume. Okay, when you find this area times the prism height, the area of that rectangular base times the height of the prism, that's what gives you the third dimension for the full volume. Okay, that principle right there can be applied to any of the prisms that you would ever see on your assignments. Okay, so I'm going to put that off over here by itself. Okay, this is something that's important. It's also going to be on the board inside the classroom. The volume of a prism equals the area of the base times the height of the prism. The area of the base times the height of the prism. Okay, so on a cube, it's the same thing, length times width times height. The only difference is that all of these length and width and height, they're all the same number. So you could just take that number and raise it to the third power. On a prism, on a rectangular prism, you do it specifically as length times width times height. On a triangle or trapezoid or whatever shape of prism, you would find the area of the base. I'll show you an example of that here in a minute, and you'll see some on your assignment today. Okay, on our first couple of examples that are on the page, the first one is a cube. Okay, your length, width, and height are all the same. So that means you're just going to take that edge and you're going to raise it to the third power. Okay, that's literally when you use an exponent of 3, that's called cubing the number, and this is why. It's because that's how you find the volume of a cube. Okay, 8 to the third power. I'm going to point this out now, and I hope it's not a problem. 8 to the third power is not 24. 8 to the third power is 8 times 8 times 8. Okay, 8 times 8 is 64, times 8 again gives us our volume of 512. Problem number 2. We've got another rectangular prism, so we'll go length times width times height. Okay, we're going to go 11 times 5 times 6. Don't overthink it, y'all. 11 times 5 times 6 gives us a volume of 330. Okay? Problems A and B, I want you to pause the video and do them on your own, and we'll see if your answers match mine. All right, pause the video now. And here's what we got. Okay, that's what we got for the volume of those other two. Okay, that is the end of the notes right here, but I want to give you a couple of hints on your Canvas assignment. Okay, your Canvas is set up so that Every other problem, you find the area of a shape and then you find the volume of a prism. Okay, this is done on purpose. Look, for example, at these two triangles. Okay, if we were finding just the area of this triangle, we know that it would be BH divided by 2. So it would be 5 times 8, which is 40, divided by 2. So the area of this triangle is 20. Now, if we're finding the area of this triangle as part of a prism, we're going to take that area, we're going to take that and multiply times the height of the prism. Okay, the height of the prism is the distance in between the bases. Okay, so the distance from one triangle to the other triangle here is 10. So that means the volume is 200 on this example. Okay, I'm going to show you one more example. It looks kind of like it. This trapezoid run right here. Okay, this is just like I was saying a minute ago. Find the volume of find the area of the base. The volume equals the area of the base times the height of the prism. Okay, so first, on this problem right here, first find the area of this trapezoid and then multiply it times the height. All right. If you have any questions, just let me know. We'll figure it out. That's all we got for today. Y'all have a good one.